Properties of definite integral example. Use properties of definite integral to evaluate this integral. As you can see, it is given that I is equal to this integral, and let's suppose this is our equation 1. Let's use the property of definite integral. Integration from 0 to a fx dx is equal to integration from 0 to a f of a minus x dx. If we use this property, I will write I is equal to integration from 0 to pi over 2 sine to the power 5 over 2 pi over 2 minus x over sine to the power 5 over 2 pi over 2 minus x plus cosine to the power 5 over 2 pi over 2 minus x dx. If you remember, sine pi over 2 minus x is cosine x, and cosine pi over 2 minus x is sine x. So using that property, we can write this is equal to integration from 0 to pi over 2 cosine 5 over 2x over sine 5 over 2x plus cosine 5 over 2x dx. And let's suppose this is equation 2. Now let's add equation 1 and 2. So adding equation 1 and 2. So if we do that, we will write I plus I on the right hand side is equal to this term which is over here plus this term which is over here. As you can see, our denominator is same, so we just have to add the numerator. So if we do that, in our right hand side we have integration from 0 to pi over 2, this term sine 5 over 2x which is over here plus cosine 5 over 2x which is here over denominator dx. And on the left hand side I have I plus I which is 2I which is over here. As you can see, numerator and denominator is same, so they will be cancelled out, and we will write 2I is equal to integration from 0 to pi over 2 dx. Integration of dx is x, so we will write x inside the bracket. This is our lower limit and this is our upper limit. Let's apply the limit. If I do that, for x I will substitute pi over 2, so which is over here, minus 0 which is over here. So pi over 2 minus 0 is pi over 2. As you can see, 2I is equal to pi over 2. So I is equal to pi over 4. So pi over 4 is the value of this integral.